Audio to the stream. Are you sharing right?
Yes.
Haven't seen.
I guess where do I share this screen? There we go.
I haven't seen it yet. You share?
Yeah. Oh, sorry. I guess it wasn't.
Okay, now it's
Sweet.
okay. It's better. Okay, so I'll just introduce you and then we get started.
Okay.
All right, good evening, everyone. Thanks for coming, and it's nice to see you. As you know, this is the third time we have, this is the third meeting after the COVID and all that has been happening. But before COVID, we used to fill up this room, so we're just getting into the mood of people coming in to meet in person. So today's presentation is going to come from John here, and he's going to talk about Kubernetes security. Falco is one of the services that a lot of people are using and talking about. I've given a talk on it before, but it's good to see someone from the company doing the work and coming to talk about it. So that came with a lot of stuff, t-shirts and socks. Also, we have without saying if you're hungry, don't go hungry because there's so much there. In fact, they always tell us if we have leftovers, feel free to go with them. All right, so we're just going to give the floor over to John to take us through the presentation, and then after that, we'll have our t-shirts on and take some photos and post them on LinkedIn and stuff like that. All right, so enjoy.
Sweet. Thank you so much for the warm introduction. Yeah, thank you also so much for showing up today. I really appreciate y'all. I just started doing more security talks, and it's really warm feeling inside to have y'all here with me, especially my number one fan, Naj, here for my last presentation. So, who's heard about Falco before? Have you seen it in practice? Okay, cool. So the majority of the room hasn't, so I'll be sure to take some time to describe what it is and show you some nice examples of how it works. So we're going to talk about securing your Kubernetes workloads with Falco. First, a little bit about me. So my name is Jonathan. I graduated from the University of North Texas with an electrical engineering degree. It wasn't the type of electrical engineering where I was working on, designing circuits and power and stuff like that. It was the type where I was reconfiguring devices that, did communications and things like that. So I did a lot of heavy programming. So that combined with my bartending experience, so I actually bartended to pay my way through school, that sort of built my character and personality. So that helped me transition into the role of a sales engineer today. A little bit more about me. I spent 2.5 years at Splunk, where I really took a deep dive into security and observability. Here at Systig now for about 8 months. And then aside from when I'm doing security stuff, I like to volunteer my time with the Society of Hispanic Professional Engineers, love to give back, and do DEI talks and things like that as well. So thanks for having me. So today we'll go over a high-level Falco overview. What is it? Why is it? We'll take a deep technical dive into Falco and how it works. I want to take you through a Kubernetes security refresher. I don't know how long it's been since you've seen some best practices in Kubernetes security, or if you know about them. And then I'll talk about specific examples on how you secure Kubernetes with your Falco instance if you choose to get one. We'll talk about Falco Plugins. Those were just released with our latest really big update. And then I'll just do a quick little chat about Systig. Okay, so to start out, cloud data breach is really expensive, right? The longer it takes for you to find it, the more expensive it becomes. So an attacker can get inside your cloud environment. Depending on what permissions they have, they can really run amok. So if I get into a Kubernetes environment, I can deploy, crypto miners, I can steal information. The longer that I kind of hang out, the more permissions that I get, the more damage that I can do. And this is from the IBM security report of 2021. So in the US alone, it's increased by over 255% over the last 15 years, from 3.45 million to 9.8 million. So what's the point of trying to make it really, really expensive to get your stuff attacked, right? If you've seen the cloud security presentation before, you've probably seen this slide. Kind of cheesy, but it works, right? When I used to work for Splunk as a sales engineer, my first question to a customer was, what type of firewall you have, right? So when I know what type of firewall they have, it's really easy to say, like, okay, is it next generation? Do you have IDS, IPS? Do you seek out malware with the firewall? It was a lot easier of a situation in on-prem times because your perimeter is guarded by that firewall. So essentially, your intrusion detection system is the firewall. If someone tries to get in, it's kind of easier to kind of sniff it out than it is in a Kubernetes kind of realm. So yeah, what does it look like now? There's no like base perimeter. So you really have to look at how your microservices and how things are communicating with each other internally. It's a lot more like a circus, right? So if I'm kind of traveling through a circus, it's a lot more like it happened to me. I can get pickpocketed, I can get scammed, whatever. The thing about cloud is it provides its own external connections, right? So the individual developer or person can decide if I'm deploying a cloud infrastructure, they can leave stuff open to the public, right? They can have a security group with SSH ingress, things like that. So it's really important to control access to the services that your team uses. And then also it's up to you to detect unusual activity in your cloud as well. So how do you do that at runtime? So with no perimeter, a security camera is super, super important. And this is a really good example to use because let's say that I have a nice big fancy house. I have locks on the doors, locks on the windows. But what if the attacker compromises that, right? What if they break in? I need to have some sort of security camera so I can identify the person that's broken into the home. Hopefully I can see their face. Maybe I can see the car that they use on the outside. So no matter how secure you can build like your fortress or the place that you stay at, you still need some sort of visibility on the outside because someone can do something to it, right? Someone can vandalize it, break in, whatever. All right, so when we talk about runtime security, that's what Falco is. So Falco is the de facto standard for runtime security in the CNCF. We have over 40 million downloads. It includes cloud risk and threat detection as well. So not only does it protect individual workloads by reading those, but you can also deploy cloud logs and things to them as well. And then we've also expanded to new event sources through Falco Plugins, and I'll talk through those a little bit later. But essentially, runtime security is really, really important these days. You can deploy a posture as secure as you want to. So let's say I have a nice secure Kubernetes distribution. I've made sure that I've closed all the ports that need to be closed, and only microservices can communicate within each other how I want them to, right? But you definitely need runtime visibility because things can happen while your Kubernetes distribution is at runtime. So Falco is really awesome. We come from a long line of open source standards. So our creator, Loris Dejuani, he co-created Wireshark. So I know some of y'all have probably used Wireshark here in the past. He also created open source Systig. So open source Systig is kind of like your container vision as a TCP dump, but it's a SCAP dump or a syscall dump. So essentially, it's trying to give you that very, very deep breadth of visibility, container visibility that Wireshark gave to like networking infrastructures. And then he also created Falco, which is your cloud native runtime security, anomaly detection, threat detection at runtime. Yeah, so like I said before, prevention is not enough. You need to have in-depth runtime security as well. So Falco definitely provides that. So we give you deep visibility into the kernel, container visibility, as well as visibility inside your cluster as well. So how does it work? So It works either with the eBPF probe or a kernel module. So what we do is we take a read of syscalls. Whenever you think about a kernel environment or an ephemeral environment with lots of containers, everything still has to communicate through a singular host. So that is like the leap forward in technology that we made from VMs to Kubernetes. When you're talking about a VM, each one of them had a separate kernel. So it's a little bit harder to take a singular view of all of your infrastructure in that regard. So it's a little bit easier with Kubernetes. Anything that happens inside a container environment needs to have a syscall in and out through the host. So even if we're talking about Docker, Containerd, CRIO, any sort of security events, PromQL, statsd metrics, host, networks metrics, it all is respondent to a syscall in and out of the kernel. So that's what Falco reads. So that's one part. The next part is mapping it to our Falco Rules engine. So essentially, the bread and butter of Falco is having granular rules that are mapped to these syscalls. The syscalls are brought up by the open source Systig module. So essentially what it's doing, it's reading all the syscalls in your environment while mapping it against really granular Falco rules to help you sniff out and find any sort of attack or anomaly. So a little bit deeper dive into how it works. So essentially, the kernel module or the eBPF probe, you can deploy both. I personally like the kernel module, but I found that on some GCP deployments, the eBPF probe is better. So, I mean, it kind of just depends. But what it is, it's a non-blocking syscall read. So we don't need any privileged access to do anything inside the kernel. So sometimes when I tell people that it needs to be attached to your kernel to read, some people get a little bit scared, right? They're like, what's it going to do to my kernel? It can mess up my distribution. But since it's non-blocking, it's really, really light as far as any sort of wear and tear on your system, if that makes sense. So essentially what it does, pulls in the syscalls. It has two separate library features that it kind of maps to. So essentially it parses the events, it filters them out, and then it maps to a rules engine. So really, really cool because you can get any sort of event. And I'll talk about later how the fields work with the syscalls, but essentially it's super, super easy to manage rules in Falco. And then not only can we take in syscalls, but also any kind of cloud log as well. So Azure Cloud Platform logs, GCP PubSub, AWS CloudTrail, we can take in any of those. We have pre-built rules from our community, hundreds and hundreds of rules that we have out there in our library. We can sniff out things like someone trying to access a key, change an IAM role, create a new security group with SSH ingress. So any sort of configuration changes. It's really kind of difficult to take a view in how people escalate privileges in the cloud and things like that. So Falco is a really, really good way to do that. Okay, now a little bit deeper dive into the architecture here. So we're a streaming architecture, so we're not a logging platform. So we don't need to take in logs and then kind of sift through them and view them after, and we don't take up space in storing data, right? It's all done through a stream. So super, super easy. We apply the rules in place, and then we send alerts in real time. So how it works. We can take in system calls, or Kubernetes audit logs, or data from plugins. So any cloud platform logs, the plugins essentially work by grabbing APIs, so essentially JSON messages, and you can write a plugin for almost anything. We have some built out for certain things, and I'll kind of go into that later, but the plugin feature is a really, really cool thing we just introduced. So just really good to put in security events from other types of data ingest in your environment. It goes into the rules engine, and then the Falco Sidekick is a good way to send messages to yourself. So we have integrations to Slack, email, S3, Elasticsearch. You can send to any sort of SIM, so Splunk, anything you can think of. We're pretty much agnostic as far as the tools that we can integrate with Falco. So let's take a deep dive into the rules now. All right, so kind of easy. If you ever played with something like Terraform before, it's just like a descriptive language, right? It lives in a comp file, and it's super, super easy to do. So essentially, you just define a rule, what it's called. The condition is where the magic happens. It's simple Boolean language. And essentially, we give you really easy to use fields. So K activity, that's any sort of Kubernetes activity. K delete, so a Kubernetes delete action. You have cluster role binding there, and then a response underscore successful. So simple Boolean logic, a Kubernetes activity, and a delete action, and cluster role binding, and a successful result. So that's essentially the super, super easy way Falco rules work. You'll have a standard output. It'll show you the source, and then you can make a quick description on it, right? So this particular rule right here, it's available inside the community. I just pulled it, but it's really easy to write your own rules as well. Falco also gives you the ability to make lists, so you can whitelist or blacklist certain things. This particular example takes a look at minor domains. So we've just created a long list of certain minor domains. If we see anyone trying to connect to them, that will send a Falco rule, right? So you can do this with any number of things. You can do things like, say, wget libraries, sudo permissions, or whatever you want to make a list from, right, to detect. And then we also have macros. So macro is just a really easy way to save a search query. This particular macro is grep commands. So the condition is just a process name and your grep binaries. So Falco makes it super, super easy to sniff out pretty much anything in your environment. Does this make sense? Does anyone have any questions about the rules? Okay, so the alerts are what outputs after a Falco triggered rule, and that's also really easy. So this one is just telling you to output in JSON. And then the output is just a simple curl, right? It's just a quick post to Slack. So nothing fancy about this. If you want your alert sent to Slack, it's just a post there. Really easy to post out anywhere, really. Okay, so let's talk about Kubernetes security best practices really quick. So I have 10 of them here. Now, really, really quick spoiler alert, Falco can't help you with all 10, but I just wanted to give you a quick refresher and then talk about what Falco can help you with. So definitely want to scan your containers in your CI/CD pipeline, right? That's just your basic number one thing, okay? Do I have a nice clean container going into my environment? Leaving a critical vulnerability inside a container, a critical CVE that's exploitable. I mean, someone can exploit it to leave your pod to go into like a control plane or another pod that has a little bit more like information in it. You want to avoid running your containers as root, right? Because if I'm a hacker, that's all I need to do is to get inside that container with root to be able to do whatever I want, like maybe read files or escalate privileges or like do some creation on my own. You want to manage users and permissions for that same reason, basically. You also want to define communication rules between pods. So the networking is internal to Kubernetes, right? So if you've ever heard of a service mesh or something like Istio, that's going to be the way that you define communication between microservices. It's just best practice because there's things like the NCD Store that if you're able to communicate with that as an attacker, you can essentially read all the secrets and passwords that are stored. TLS, so TLS between microservices as well is really important. So your service mesh can actually take care of that as well. You want to secure your secret data. So whenever you have a Kubernetes cluster deployed, like let's give an example of AWS, you can do like a get secret or a get password. So typically like secrets and passwords are stored somewhere inside that. And it's super, super easy to access those. So securing that secret data is really important. You need to secure your NCD store. So that's where all your backups are stored, essentially passwords, secrets, and things like that. So a really smart hacker move is hacking into the NCD store, changing key value pairs there, and that results in changes in your actual infrastructure. So that's like a really big security gap most people don't realize. Automated backup and restore, right? So if I'm a hacker and I steal your data, I can say, give me $1 million and I give it back to you. But that won't happen if I have a backup, right? Configure security policies. So essentially when deploying Kubernetes, you want to deploy them in best practices. Security policies will help you do that, help block out any like ports you want open and things like that. And then you definitely want a good disaster recovery as well. Okay, so that's a lot of stuff. Building an end-to-end Kubernetes-based DevSecOps software factory, you can see that there's a lot more that you need for security other than Falco, okay? So Falco will help you out in runtime, but there's also some really good open source stuff that you can use to help you with the other things that I mentioned. So Get Secret, that's gonna help you encrypt your NCD store so people can't read that. Anchor and Sneak, you definitely want to scan your containers and you want to scan your libraries and dependencies, right? OWASP, so there's several projects in OWASP that can help you with dynamic application security. So for those like really specific attacks, and then you need Falco for runtime security as well. All right. Let's start taking a look at those security best practices and how exactly Falco can help you out. All right, so running containers is root. If an attacker gets access to a root container, they can break out from that container, access the host or worker node, and they can easily escalate privileges. So with Falco, you can sniff out any instance of a container running as root user the moment that it happens. So with this rule, we're just looking for a new spawn process. So the new spawn process was a container, and this container has like root access. So really, really easy to sniff that out. With Falco, there's not really automated responses, so you're responsible for building those out, right? But this easily can help you with the granular data that it gives you. It can help you point to the container that was run as root where you can help do some automated reactions. Okay, so managing users and permissions. A super great way to do this is role-based access control, right? So a good practice that I like to tell people is you don't need to have your Kubernetes admin be the same person as your like developer that's going to be doing things. So really, your Kubernetes admin just needs to be like provisioning access and things like that, or provisioning resources. Your devs really only need to view, create, update a deployment, a service, or a config map, or view and list pods, right? For a cluster role admin, they can create, view, and delete nodes, namespaces, or volumes, but the key idea behind managing users and permissions is if a permission to a service account gets compromised, so attackers can send requests to the API server and they can create, change, or delete resources, right? So super, super big deal. So how does Falco help you deal with this? Well, one, we can sniff out if anyone has like full administrative access. So this is like good if someone just escalates privileges for themselves and gives themselves full admin privileges. You can sniff out the moment that that happens with Falco. And then also small things like if someone tries to super use or something, like does some sudo, escalate privileges through that, you can also sniff that out. So, I mean, Falco's really cool. So like sudo, that's a cool thing to sniff out, but like any sort of command like apt-get install. So say that you've created a container that's really lightweight. So you don't want them to be able to install new things on there. So you can sniff out those type of commands as well. And here to the bottom right, this is just a list of other types of rules that I also have. So if any Kubernetes service is created or deleted, any service's account is created or deleted, or service account is created in a kube namespace, you can sniff that out as well. So really granular with the rules. Okay, so you want to define communication rules between pods as well. You really only want them to talk to the people that they need to. So like least access allowed rules are really, really important. And you definitely want to deploy network policies through a service mesh as well. So Istio is a good one. But by default, all pods can talk to each other, right? So Kubernetes is just like cloud in the regard that it's like a shared security model, you know? So deploying Kubernetes isn't enough. Once it's out there, you need to restrict access to what the pods can say to each other as well. So with Falco, after you have defined all your really great network policies with your Istio, and you've defined how your microservices should be communicating with each other, you use Falco to make sure that nothing strays away from that, right? No new connection is made. So this particular Falco rule is telling me if any new outbound or inbound traffic is coming to my microservice. This also tracks server process and port as well. So if any new port is opened, also if any new process is spawned as well. So that gets into like the zero trust security. Whenever an attacker gets into your pod and like they curl something in, there's always a new process that happens. So if you can alert with Falco when a new process starts, that's like as zero trust as you can get, basically. Is this making sense? Good? Good. Cool. Okay, so you also want to secure your secret data. So Falco doesn't encrypt anything, right? By default, secrets are stored unencrypted. So if an attacker gets in, essentially they can read all the sensitive content super easily. So you can enable encryption configuration resource, but you'll still need to secure the key with something like a HashiCorp vault, for an example. But if you're not able to, I guess, pay extra money to get some sort of like encryption inside your pods, you can use Falco to sniff out whether or not someone's using like a get secret type of value thing. So this particular rule is for AWS. If someone tries to get secret value and there's no like error code, then this will sniff that out. And also, we can also sniff out if someone like creates or modifies a new config map with private credentials as well. So if I'm an attacker and there are like granular rules set to either config maps or service accounts, what I would want to do is create a new service account aside from that, or a new config map. So this will help sniff that out. Okay, so securing the NCD store. So this is a really big one. If an attacker can get access to the NCD store, they can bypass the API server and make changes directly to the NCD store, which will result in Kubernetes resources being updated. So essentially, they can do whatever they want in that point. You know, create a new pod with their crypto miner on or whatever. So with this particular Falco rule, we're just seeing if any unexpected node port connection is made. You can do it with, again, like we did the last rule, with any unexpected connection to a new port or a new process. This is just giving the example of a node port. Okay, so configuring security policies. So essentially configuring everything to best practice. That usually means something like being really tight on the ports, processes that are inside the container, and then it not running as root. But someone can always launch a root user container at runtime. So essentially, you need something like Runtime Security or Falco to sniff it out. So I guess that's like the main point that I'm trying to get across to you is you can build something as secure as you want it to, but at runtime, things always change. So you need some sort of runtime security to sniff out changes to your best practices in your environment. Okay, so MTLS between services. So with Falco, it's really easy to sniff out a new ingress object that was created without TLS. By default, communication between pods is not encrypted. So if an attacker gets inside, they'll be able to see all the communication between pods in plain text. Yeah, so you want to deploy a service mesh to apply MTLS between services. And you want something like runtime security, just in case someone tries to create a new ingress without it. Cool. So just to like dive a little bit deeper on plugins. So we created some new ones. CloudTrail is a really, really big one. So being able to get those CloudTrail logs and alert off of those. And then another new big one that just came out is Okta. So if you use Okta at your company, we can get in Okta logs and then do Falco alerts from those as well. So essentially what that looks like, we built two like plugin examples. One is built in C, one is built in C++. Super, super easy to follow to get whatever technology you want inside of Falco and alert based off of it. Okay, so Falco's the open source version. We also have a Systig secure version as well. So essentially the enterprise platform that we built on top of Falco is just giving you bundled rules and tagging them out essentially. So the new functionality is we just give you rules to pull from a library, right? And then Systig, the secure platform, also gives you ways to scan images for vulnerabilities, and then a little bit more deeper breadth into like network security. So if anyone's interested in talking about enterprise Systig, you can talk to Lindsay or I afterwards. Okay, sorry, that went a little bit fast, but that was the presentation that I had for you today. Anyone have questions?
Yeah. So Falco is not just for container, right? It can be used for Linux application as well.
Yeah,
right?
correct. Mm-hmm.
As long as you define the rule to it's built on top of the eBPF or
Yeah, built on top of the eBPF probe. So essentially, anything that's attached to a syscall inside your Linux environment, you can create a Falco rule for it. So I mean, there's thousands and thousands of syscalls. We already have several fields built out for you, but if we don't, it's really easy to add another one. Mm-hmm.
Is it standard set of rules on top of that we can customize it or
Yeah, so
adding on to custom rules?
right. So whenever you install open source Falco, it doesn't come with any rules, so you have to define all the rules that you want. But the cool thing about Falco open source community is there's hundreds of rules that are written for you out there already that you can just pull from. So, I mean, if you can think about it, like for a Kubernetes or like Linux environment, most of the rules are written already, you know? And then what's up to you after that is just scoping them out for your environment, like adding them to a specific namespace and not another one, you know?
The Falco, right now they're alert. Let's say I'm going to say if you some container open certain port,
Mhm.
can it be behind that port, or can I have to create some script to trigger kill that container myself?
Mhm. You would have to create the script to kill the container yourself. Hmm. With the paid version from Systig, we have auto remediation. For open source, it's up to you to write it yourself.
Another question is in the enterprise version, you guys have, I don't know, have some kind of AI feature to do alerts? I don't know, like, or, it's either some product folder is like, I don't know, it's black magic, but.
Yeah,
It's
right.
pretty good.
So we have two different things. One is like a learning module. So we take a read of containers in your environment. So long that you're pushing the same image and no security events happen, we can learn that that's a good deployment for you. So we can click into the image and then we can tell you, okay, these ports are good, these processes are good, these syscalls are good, and then you can create a Falco rule set based on that. So let's say that someone opens up a new port, a new process spawns, then you'll be alerted because it's behaving abnormally. The other module is if certain rules seem to be firing off that don't mean anything to you, we have like a rule tuner to help cancel out like noise. So a good example is some like root container processes spawn off automatically. For an example, if you spawn Falco, it needs like some sort of like special privileges, so it'll alert on itself. So you'll need to like tune stuff out like that.
So do you have kind of a, I guess the examples you gave, you could implement with a validating webhook admission controller, right? You could just like deny pods that use root or deny pods that use certain ports or host networking or what have you. Do you have kind of like a recommendation for when might you block access yourself using kind of configuration management, I guess, for lack of a better term, versus when would you instrument with Falco?
That's a good idea. So I think for like a good zero trust environment, you should always instrument to block certain behaviors. At runtime, things can change though. So let's try to find a good example. If someone accidentally clicks a link, they can curl in like a root process into a container. So like for that instance, you would want to have Falco running to sniff out like a new root container being opened up in your environment. So like you really need both at all times, you know.
So the idea is kind of that like if your configuration slips or lets something through, like another.
Yeah.
I guess another thing that comes to mind is like honeypots. Like I have set off Falco at my job before by doing things and giving nasty emails.
Yeah. Yeah.
Useful also, but anyway, that makes sense.
Yeah, it's meant to be your last line of defense, you know.
Yeah, the question I had was about cloud trail. When Falco was an API calls, is there like the cost implications? Is there like a rate, a defined rate at which it's proving cloud trail for the API calls? Because I'm thinking of the cost implication. If you have setting, if you have like cloud trail running naturally in AWS, Falco is also making the API calls. Like double your expenses. How do you, is there a way you can limit the rates?
Right.
Which Falco makes those calls to cloud
Gotcha. I actually need to look a little bit more into that, but from my understanding, you don't need to like pull from the API in Falco. It streams through. So like those CloudTrail logs, if the agent is in place, they stream through it in a little loop. So they never get caught by Falco unless it sends an alert. So essentially, we're not taking a like read of everything at once. It's kind of passively reading and being mapped against the Falco rules through like the two libraries. And then if something gets caught, then it spits it out. Does that make sense? But I can follow up because I know that there are some costs that are incurred with that. I'm just unprepared for that question. Sorry. Yeah.
So how do people get started? Is there a simple way for them to go and start learning?
Definitely. You want to go to falco.org. Super awesome place to go. Falco.org. You can go everywhere from there, you know. You can access the community library of rules. You can get the agent install and like everything from falco.org, all the docs.
And what's the difference between the free version and the paid version?
So the main difference is a fancy UI and also pre-bundled rules that you can pick from a list. So whenever you do the open source, you can read the rules that are there in the community. So essentially you're copying and pasting. With the paid version, all the rules are bundled inside your SaaS instance, and then you point and click. But the more convenient thing is they're bundled into rule policies. So I have something like a Kubernetes rule bundle that'll have 20 different rules that are all about Kubernetes best practices. So essentially it's Falco with all the setup and things like that. And then you also get stuff like vulnerability scanning. So you can scan your containers before they get to build, also at runtime. And we also have like CSPM. So you can see if like S3 buckets are open. You can see CIS benchmarks and how you deploy things as well. Yep.
So if I understand it, Falco does mainly detection, right?
Mm-hmm. Yep.
So in the commercial portion, how is there a way to do the prevention? Is there a commonly used application with Falco?
So you mean in the paid version?
Yeah.
So in the paid version, it's called Systig, and it's all roped in together. So with Systig, we leverage like Docker and Kubernetes native commands. So if you find some kind of container behavior that you're not liking, we can like auto stop or kill or pause the container for you to take a look at. And then we also leverage the Systig open source as well, so you can take a capture of the container and then dig into like what commands the user was making, what files they were interacting with, and things like that.
What's the effect of the resource on the cost? What's the effect of the resource?
Right. So marketing answer is like super negligible, but I can't remember the exact resource implications, but it deploys as a daemon set. So it attaches itself to each pod inside your Kubernetes cluster. And it's something really, really low. It's like two CPUs. But it's really low, really negligible as far as like reading.
So is the commercial version Systig secure, or is that something different?
That's the commercial version. Yeah. Mm-hmm. Yeah, there's Systig Secure and Systig Monitor. Monitor is enterprise Prometheus, basically.
I guess related to performance, if you don't mind, can you speak a little bit to the life cycle of an event? Like from the eBPF probe, do they get like filtered on that post before they get aggregated back to some central process, or kind of how does that look?
Yeah, that's a good question. So the actual and I don't think I put it in here. Yeah, I didn't. So there's a ring loop here in the middle right here. So we're streaming essentially in and out, but it has to satisfy 16 megabytes of data going in before it ever leaves. So essentially the processing happens inside the ring loop. So from syscall, the syscall happens, Falco reads the syscall in a non-blocking way, passes through the ring loop where it's mapped to the actual rules engine, and then it spits out the alert via post or however you want it. So it's really it's a good word for it. It's really like non-invasive type of alerting.
So that all happens on the node that the event originated from?
Mm-hmm. Yeah. Mm-hmm. Yep. Mm-hmm.
Is that it?
I think that's it.
So in the absence of any more questions, all right. So this should be one of the shortest meetup we've had in recent times, but it's fine. Normally we try to have two speakers. You know, the first speaker maybe focus more on beginner-friendly topic, and then the second might be like what John just talked about. Because we realize that in every meeting we have new people coming in, and most of these people they may not even be familiar with, Docker and Kubernetes and the cloud native ecosystem. And certain topics like what he talked about today, if you don't even understand the architecture of Kubernetes, it's difficult to comprehend it fully, all right? So from next meeting, I think we're going to start to introduce that again, have kind of like overview of Kubernetes and the ecosystem and the architecture and stuff, so that when the next speaker comes to talk, then maybe things can click more, all right? So, but I think it's a nice evening. We're going to have the opportunity to take some photos. Like I said earlier, have our influencer on LinkedIn and promote to all the group that he speak to. In the meantime, we always need speakers, always. So please let me know if you have a topic you'd like to talk about. Now, it could be something you're working on. It could be something that you think you can talk about. So don't think you have to be super, super expert, okay? But any project you're working on, feel free to come and talk about it. So by a show of hand, is anyone here who might have something to talk about? Yeah? Something you're working on? Maybe you can do the beginner sessions.
Yeah, maybe the beginner sessions.
Okay.
I just internally have to work out the permission
Okay.
for like speaking
Okay.
to external parties as well.
Okay.
It's something
We've been
that-
working on it.
Yeah,
Okay.
it's something that we're
All right.
working on, so
Okay.
hopefully we'll have some kind of update for you.
All right. Let's keep up the communication,
Yeah,
and then we'll see
definitely.
what to do. Okay. So again, if you have something to talk about, like I said, please always feel free to let me know, or Himansu. By the way, this is Himansu Patel. He is my colleague that we're organizing the meetup together. So I think that's all from me. So maybe now we can just chill out and have some pizzas and have some drinks and take some photos and on and on. But thanks for coming. And then, do you want to say something, Lingston?
No, I mean,
Okay.
if there's any other questions or anything, I would love to have,
Okay.
contact information. I can always kind of, tie off with Jonathan as well. And
Mhm.
any of our product team, if you guys have questions about roadmap, Systig as a whole, anything like that, we're more than happy to discuss. So just let me know. We have a Falco focused team as well. So if we do podcasts live, we just came out with another book, our creator did it. So lots of exciting stuff in the open source community as well. But
Okay.
yeah, thanks
Yeah.
all for coming, and please take any slack you might.
Okay. Okay, so everyone had a t-shirt, socks. What is this? I don't have this one.
I think everybody can take 5
Like,
seconds.
USB. Is that the USB?
Oh yeah, they're phone chargers.
Okay. So. Yeah.
So
It seems to be light over here, maybe it's better over here.
that light can be turned off.
And then a ton
So we actually have a Prometheus exporter from Falco Yeah.
So our.
Yep. Yep. So we,
I know.
essentially, we replace the one but it has like a lightweight Prometheus server inside. So a lot of people who are user based, this is great for me.
I'm literally taking a training now because honestly, this is big shiny object.
Yeah.
Being a infrastructure, I don't want to be on that.
But not as much as so we're.
Yeah, I love see whether it's work. Whether we can go and sleep. Physical.
Yeah, but I think.
What's the virtual storage? Right, you know, why do customers, why do people care?
Oh, really?
So I guess the.
They want to go painstakingly rip out their money, but they out.
It runs as the container inside.
How much you think?
Microservice. Why did they want to go for that?
Not at all. Right. Yeah. I've never heard anybody complain about resource intensive.
I think I can stop the stream. So I'm going to